This conference will now be recorded.
Hello, everybody. Jordan Girth here with the National Weather Service Office of Observations. Thank you so much for joining us for the Satellite Book Club Seminar Series. This is session number 208. The title of today's presentation, it's a long one, Utilizing Remote Sensing in NASA SPoRT Land Information System, Alaska, to improve flood and landslide situational awareness from heavy precipitation in Southeast Alaska. This is a timely presentation in light of recent events. Our presenter today is Aaron Jacobs, the Senior Service Hydrologist at the Weather Service Forecast Office in Juneau, Alaska. And we'll have the discussion following Aaron's presentation facilitated by Jarell Torres, the Research Associate and Satellite Liaison for JPSS from CIRA. Just a few reminders, as you heard, this session is being recorded, so please mute your microphone, and if you are not presenting, turn off your webcam. There will be an opportunity for Q&A after the presentation, so please post your questions in the chat and we will field them in the order they are asked. If you have signed in with an office account, please note your name when asking a question so we can follow up if necessary. We're always looking for future presenters. Would encourage you to perhaps give a presentation you recently gave at the National Weather Association annual meeting, or will plan to give at AGU or the American Meteorological Society annual meeting. Please reach out to us. We'd love to incorporate that into the Satellite Book Club Seminar Series. And the link to contact us to be a presenter or facilitator is there in the chat. Thank you so much, Emily. The training team can help create training materials that may be unavailable or point you to materials you may be unaware of. Russ Van Til, the Office of the Chief Learning Officer, can help with that. I'd like to thank the Office of the Chief Learning Officer, the GOES, or the GEO and LEO programs, our presenter, facilitator, all of you for being with us today. And last but not least, Emily and Kashad, members of our TowerS team who work tirelessly to put this program together and coordinate each and every week. It's very appreciated. All right, without further ado, as I mentioned, Aaron Jacobs is the Senior Service Hydrologist at the Forecast Office in Juneau, Alaska. In this role, he is responsible for the National Weather Service Hydrology Program of an area equivalent to the size of Florida, from the North Gulf of Alaska coast through the Panhandle to Dixon Entrance. Two priorities of managing the local NWS Hydrology Program is to improve flood forecasting by acquiring increased precipitation information across Southeast Alaska and provide hydrologic water supply information to the public of Southeast Alaska. Aaron specializes in hydrometeorology, remote sensing, debris flow, drought, and atmospheric rivers. So Aaron, we're glad to have you with us today. Welcome.
Thanks, Jordan, for having me, and to everyone else for coming to this talk. I've been a long time listener to these presentations and talks, and I'm glad I'm able to present to you all on what I have to show today. So first, I'm going to kind of outline what I'm going to talk about. It's going to kind of bring you into Southeast Alaska with our conditions and limitations that we have in ability to forecast heavy precipitation, and then the impacts that are associated with it. And then so I'm going to be showing a case study of the impacts and record precipitation from this December 1 and 2 from 2020. It was a rain on snow atmospheric river event. And then from those impacts, I'm going to show you how the polar microwave products that were available to the forecasters and how we were able to use it to assess this heavy precipitation moving over the region. And then see how in conjunction with those rain rate products of how we can utilize this land information system that we were getting from NASA SPoRT. And then just the case study findings of what we were able to learn from these from this really high impact event. So first, I'm going to fly you into Southeast Alaska. Let me go back to this original slide here. And here's the big state of Alaska. And then in the circle here is where I am located in Southeast Alaska. And like I was saying, it's about the size of Florida. And we have one forecast office right here in Juneau. And we are responsible for this whole area circled in red. And so with that area, we are the third largest weather service area responsibility, including the water too. My other forecast offices in Anchorage and Fairbanks are number 1 and number 2. But you can see that we have a lot of land, and then there's also a lot of water. So 75% of our forecast area is covered by water, and that's why satellite information is so vitally important for our situational awareness of weather conditions across the region. And so another thing about Southeast Alaska is very complex terrain, and so this circle box here is kind of just showing you a zoom in area of the northern inner channels, and the steep terrain kind of goes from average area goes from sea level to 3,000 feet in less than 3 miles. And in some cases along the outer coast here near Mount Fairweather, it goes as high as 15,000 feet in 8 miles. In the image to the right is a zoomed in image right here. This box is called Skagway, and just to show you the relief and how quick the mountains go up from sea level, and how complex it can be. This is a nice gap that goes right into the interior of Canada, and this is a very windy location, and can definitely get some heavy precipitation with those mountains right in the way. So in the way of precipitation, this is the largest temperate rainforest in the world, and our mean precipitation varies immensely from our area. So here in the southern areas, or at least across the region, you can have as much as 200 inches in a year. And most of the other locations, like in the Juneau and along the Coast Range here, can range from about 78 inches to about like 100 inches. But up here in the northern channels, you can already have like as little as 40 inches of rain. So there's a wide variety of climate variability and precipitation variability across our region. And to be able to monitor precipitation, radar is not really the way to go for Alaska. Here's just an image of how many next-red radars the lower 48 has, and the coverage that they have. And then the image to the right shows you what Alaska has. So we only have about 7 radars across our area compared to 140 over the CONUS. So, and then most of these radars that we do have are beam blockage. So they do give us some information, but doesn't give us the whole story. And so here's just an example of what of those beam blockages would look like. So here's Southeast Alaska and Bjorka Island. This is where our radar is, and you can see some precipitation over the Gulf of Alaska, over the Eastern Gulf, but here to the right of the radar, where you can see no echoes or no returns, it's not saying necessarily that there is no precipitation falling in that area, but we have a large range of mountains right here around. It goes up to 6,000 feet. So most of that beam gets blocked over the communities and where we have locations at people. And so kind of getting into the event here, first I'm going to, instead of showing you the conditions of what led to these impacts, I'm showing off like what impacts took place in this event. And they're far and wide, and unfortunately we did have a couple of fatalities in Haines here. And so here's just some impact pictures from the landslides, and then also the flooding that took place up mainly in Haines in these set of pictures, but there are some from Juneau. But this is the big Beach Road landslide that unfortunately took 2 lives, and then a couple other land movement along in the Haines area, and then pretty significant flooding due to this rain on snow event. And then from the flooding aspect, here's 2 individual areas in Southeast Alaska. One is in Gustavus off to the left that saw very significant flooding. It was like 3 to 4 feet of water over these roads into these homes. And this is the hydrograph of what the rise of the river did on Salmon Creek in Gustavus. It rose almost 5 to 6 feet in less than about like 36, 48 hours. And this was a fairly significant rise, and it did last a very long while into the flooding areas. And here off to the right shows Jordan Creek in Juneau, and there was a record flooding from this event. And again, you can see how steep the water rose through this time of this event from not just the heavy precipitation, but again, the snow melt that did take place. This was a record event for the Jordan Creek area. And so now kind of looking at the moisture setup, kind of getting into the satellite products that our forecasters were able to look at. Kind of showing here the total precipitable water, and then with the layered PW product that are available. And it really provides great situational awareness of this evolving atmospheric river, and kind of shows the structure of the total precipitable water that can produce these heavy rain rates over to the Gulf of Alaska and the North Pacific. So kind of step you through the time frame. So here's December 1st at 0Z, and here's our impending atmospheric river. But down in here in the North Pacific, you can see like two areas that are going to be merging together into one larger, more significant atmospheric river in 24 hours. And then this whole band of high precipitable water just moved right into the eastern Gulf of Alaska and then pretty much went through the region. And then looking off to the right, this is looking at that instead of the total, looking at the slicing of the atmosphere into these 4 different layers. And you can really see that structure down here at the upper levels of the wave kind of merging into the main stream of moisture coming through the time frame. As you move down into the 12Z time frame, you can really start seeing that added moisture getting convected into the main plume that was moving over the region. Another thing with this product that our forecasters can really utilize is just the depth of the moisture going all the way up to 300 millibars, and it's really indicative of when the heavy rain or the duration of the heavy rain could persist over the area. And then here's just how that layered product was able to move that main plume from 0Z on the 2nd, moving it up into the region. And as you can see, very deep moisture all over the eastern Gulf and then over southeast Alaska at all levels of the atmosphere. So again, this is really indicative of really a lot of moisture available and the heavy precipitation moving over the region. Then moving into, as the cold front was moving through the region, you can really see how that upper level moisture really starts to diminish as the front or the cold front moves through the area. And then by 12Z on the 3rd, you can see that a lot of the heavy moisture has really kind of moved out of the region. We really started to see a lack in precipitation by this time frame. And now getting into the rain rate product, so you kind of take all this moisture available and you see this deep moisture through the atmosphere, but how's that producing the precipitation? So these solid rain rates that the forecasters has at our availability within AWIPS, we have a MIRS product, we have a GPM product, SPoRT, and then a GCOM. And unfortunately with the GCOM, we only have one satellite that produces rain rates, so the coverage is not as great, but the MIRS, the GPM, and the SPoRT are really great situational awareness tools for our forecasters to really track these events moving over the Gulf of Alaska and then into the into southeast Alaska. And so these boxes are really just showing the really high rain rates that were moving over the region and taking place over the northern panhandles. And a lot of these rain rates varied from 0.2 to almost a ½ inch per hour. And as these pulses moved over, you can see in the boxes, that's where most of our impacts really took place. And our forecasters were able to really utilize this information to see where the heavy rain was taking place and then try to message that in our products. And then the last image down here on the bottom right, you can really see how once that cold front moved through, a lot of the rain rates offshore were not as intense. So we knew we were kind of on the back end of the event. And here's just another example, a couple other the product and rain rates as the atmospheric river was really moving through the region. And you can really see the great structure that these satellite products can provide to our forecasters. These two images in the bottom, you may see that, think that they're looking a little odd, but this is from the MIRS algorithm, and what it's showing is it really doesn't do that well over ice and land, but it does do well over water. So what this is indicating to the forecasters that you have really good returns of high rates over the waterways, but maybe not so much over the land. And also in this event, we're having some snow, so the MIRS also kind of doesn't really show the snow because there's another product, the snowfall rate product, that helps indicate the wintertime precipitation in those events. But again, these products are really indicating high rain rates, and providing that information to our forecasters were really imperative in this event. Now, how do you put all this information together to help to understand what the impacts can be? So this is the NASA SPoRT was able to develop this land information system for Alaska, and it was in a development stage, and it was kind of looked at just on how the forecasters could utilize this type of product to kind of have an idea of what type of impact could take place. So first, I'm showing what this is the runoff component of the LIS-AK. And so essentially what this is showing the forecaster is essentially any water doesn't go into the soil because of the soil saturation is too high, gets kind of represented as a surface runoff. And then that surface runoff can get diverted into our streams. And so these values may not seem that much. You're only looking at maybe very low amounts, like 0.2 of an inch every 3 hours, even as high as less than an inch. But this is over a 3-kilometer grid, and if you kind of route all that water into our smaller stream systems, it can have large effects on that flow. And so what you're seeing here from the left to the right is, as the event was kind of ongoing, you can see how the surface runoff was really increasing through time. So the 3 circles that I have up here is the Haines and Skagway area up to the top. Here's the Gustavus area over to the left, and then here's the Juneau area on the right. And if you keep notice on these 2 areas, as you move to the right in the first 2 panels, you will see as the heavy precipitation moved into the region, you were seeing a lot of runoff, and that was also due to the rain on snow and the snow component of the melting. And so this was really giving some really good indication that we were seeing a lot of runoff that was going to be taking place from the precipitation that was forecasted. And then through time, here's in the afternoon on the 2nd, you can already start seeing some of that runoff that's decreasing. And then again, here's on the later in the evening on the 2nd, and that runoff has really decreased as that cold front pushed through. So the real time frame was right in here in the afternoon of the 1st into the afternoon morning of the 2nd, where we were really seeing a lot of runoff, and we were actually starting to see some reports of these impacts taking place by this time frame. And so there's that snowmelt component that I was mentioning of that could really help with that runoff. And so this is another output that the LIS-AK can provide to our forecasters in showing, again, the increased runoff during that high precipitation time frame. And also with this atmospheric river really seeing very warm temperatures. Our freezing levels were going as high as 5,000 to 6,000 feet. So we're really melting not just the snow, but everything above it, even the glaciers and so forth. So there was just a significant amount of melt that was going on, and that was all going into our soils or going into our rivers that was causing all those impacts that we're showing. And again, you can see as you go through time here at the bottom, that melt really decreased as that cold front pushed through. And again, kind of indicating to the forecaster of when the highest risk of impacts could take place, and then seeing if we could really better message what those impacts could have been. So findings and the kind of closing thoughts is that the biggest impact to these satellite products for our forecasters, the low latency and the direct broadcast. We're able to really get this information really quick to our forecasters, and that really improves not just the temporal and spatial situational awareness in our area, but this is really a great tool to help us with those data void areas in our where we don't have radar. And then with utilizing the LIS-AK, it really helped to identify the increased amounts of not just the runoff, but also the snow melt. And those are really hard for our forecasters to deduce, is pretty much how much runoff or how much melt we can get from these bigger events, especially in our shoulder seasons. They've been on our higher impact classifications. It's not just the atmospheric rivers, but when we have these rain on snow atmospheric river events, that seems to be when we really see our higher impact events. So getting a better idea on the amount of runoff is really important to not just our forecasters, but also the hydrologists over at the River Forecast Center, which does help us with our river forecasting. And the reports of severe impacts really started in that early morning time frame and then continued through December 2nd. And a lot of that information that we're seeing on the satellite rain rate products and even to the LIS-AK was really indicating that was the real hotspot or timing of when the runoff was the most, the precipitation was the most, and the impacts were really cropping up at that time frame. So the usage of the LIS-AK in operations could really increase our lead time in what these potential impacts could take place, and then how we could really get those warnings out in specific training from our forecasters also to understand what is the output is, because it's still experimental. We're still trying to get a feel for what values when we start seeing impacts. But the combination of this LIS-AK output along with these polar products in near real time can really, again, increase our situational awareness and provide that IDSS to our emergency management personnel. So the image to the right here is showing that combination of a snowfall rate product and also the MERS rain rate product. So this is that combination where our forecasters can not just use the regular rain rate products, but try to bring in how much snow is actually falling in the cloud to help with those impacts at the same time. So with that, I will leave some questions, and there is a story map for this event that we developed, and there's a link to it from this presentation, or just reach out to me and I can get you a link to it. But thanks again for listening, and I'll take any questions.
All right, thank you, Aaron, for that great presentation. And what we'll do here, before we go to Q&A, I just have a few updates for the attendees online. And we just wanted to mention that we want to encourage attendees to please stay on for the Q&A. And also, we also encourage participation from the field forecast offices, regional HQ, and others. And we also want to encourage everyone to change their viewing settings to active camera within the GoToMeeting interface there from the default view. And I would also like to mention as well that please stay tuned for updates from the TowerS team on next week's presentation for October 3rd. And then we would also like to encourage attendees to contact the TowerS team, Kashad Bowman and Emily Maddox, for questions about the SBC or for configuration of satellite products. Now with that, we will transition here to the Q&A, and a reminder to folks that you can submit your questions here in the chat. So please add your questions there, and we'll get started here. Aaron, and one of the questions I have for you, Aaron, you were mentioning landslides and those impacts, and I was curious from this particular event, and then also maybe more near recent events, how large, like spatially, are these landslides that are occurring within your CWA?
I wouldn't say that they're large, nothing like an OSO kind of landslide, if people understand what the OSO landslide in Washington was. But these are happening in smaller valleys and basins and such, so they are fairly on the smaller side, but so we're not really looking to see that we can warn on these individual valleys or basins in these, but we're looking at more of a spatial distribution of these higher rain amounts that could lead to these events. So it's very small scale events that are taking place, but there are some indications of what we can monitor of getting a heads up before these events take place. At least give it an idea of where you might want to move for the night or something like that, where the risk could be higher.
Okay, and then also I think because we were both in Alaska for that Alaska meeting 2 weeks ago, but remind me again, you guys had a few landslide events within the past few months or past year, correct?
Yeah, so we actually had, unfortunately, a deadly landslide here in August in Ketchikan. We had one person fatality and a bunch of other homes damaged and such. So, and then before that, we had a one in Wrangell, Alaska, that last fall in November, and that took the lives of actually 6 people. So yeah, these events are happening more and more, at least affecting humans more. So the Weather Service, along with our partners, are looking more and more into these events to see how we can help the public prepare for these.
Fair enough. And then a quick transition to another question here I have. So you're showing a lot of the different satellite data sets that you utilize, whether it be from the microwave point of view there. And my question to you is that for you and your forecasters at WFO Juneau, do you guys utilize the usually access the data when you're in operations on mainly in AWIPS or also some online resources as well, or both?
So most of the time that we will, most of the data that I was able to show is in AWIPS, so our forecasters are able to do that, and that's definitely the help of TowerS to get some of those products into our forecasters' hands, especially the SPoRT 2 and even the LIS-AK. That was a little of a push where it was just on a web page that NASA SPoRT put together. And that's say Clay Blankenschmidt really helped develop that LIS-AK. I see that he's online here. So really appreciate his efforts into getting that tool for our forecasters. But yeah, so there was a online tool visualization that our forecasters were able to view through NASA SPoRT, but we were able to get it into AWIPS, and we're able to view it now that way. And similarly with some of our satellite products, we can view most of them in AWIPS, but there are some applications or times that we would want to see it on the web for maybe messaging aspects, and that was through the slider or the real Earth for the SEAMORPH 2 data.
Okay, awesome. And speaking of the NASA SPoRT LIS-AK data, is that data publicly available online, or is it more or not?
It is available online, and we can get you the link to that. And that was the main impetus of, or the main place to get it at first. And through Clay's help and NASA SPoRT, we were able to get some different views in there and different training for our forecasters to help understand what those outputs are. So I know there's some other work kind of working on that from NASA, is that they're looking at the land information system for a third version that is actually going to encompass the whole North America at a higher resolution. So we're kind of working on seeing how Alaska can benefit from that new application.
Okay. And I see that we have a question in the chat here from Curtis Seaman here at CIRA. And he asks, are there any CoCoRaHS observers in the SEAC, and how many ground truth sites do you have for rainfall?
That's a good question, Curtis. Yeah, there are some, we do have some CoCoRaHS observers in the region, and we are gaining more and more every year. And so we did some verification from the satellite rain rates to the ASOSs for this event. And for the most part, the satellite rain rates really did indicate the timing of the heaviest precipitation from the ASOSs and some other ground truth places. So there was some really good validation that the rain rates that we were seeing were happening at the ground. And so for how many ground truth surface locations that we have, it's not many compared to the lower 48. We have about 70 to 80 real-time observations for precipitation in Southeast Alaska, but I would say majority of those are not the greatest in wintertime operations. So that is a big detriment to our operations from a land-based observations, is the wintertime precipitation and the lack of good observations at especially high elevations at the same time.
Right. And I believe earlier you were mentioning, or briefly mentioning, the snowfall rate product. My question to you is that for you and your forecasters there at Juneau, do you guys mainly use just the liquid equivalent snowfall rate product that just has the polar beam SWATs, or do you utilize the one that has the merged SFR, which incorporates the radar in operations?
That's a good question, Darrell. And you know, first started out the presentation with the lack of radar coverage that we have. So that merged SFR is not the greatest. I don't think it's being worked on in Alaska due to our radar coverage, but our forecasters do utilize the snowfall rate product in conjunction with the other snowfall rate products that we have in AWIPS.
Awesome. And let's see, I see that Jonathan Case put in the SPoRT LIS instance over Alaska there with the link. So great. Thank you, John, for that. He also mentions that the pull down menu under dataset shows various zoom regions, including from the Alaska run. Product shows different variables. Or I guess dataset LIS pull down menu. So just some complementary information there. Looks like we have another question from Quetzal Levens. Have you been able to verify the accuracy of the snowfall rate products with SNOWTEL sites?
Great question. Yeah.
This is Clay. You're asking about the list?
Possibly, Clay. Why don't you go ahead and speak up? Sure.
So for the list, we did do a snowfall validation. We had an AMS poster about it 2 or 3 years back. I can post a link in a minute. And it matches up really well except for a few spots along the coast.
Awesome. And about the snowfall rate product, I know Wan Meng and her group did look at some of the SNOTEL information, and then there were some other snowfall stations that we had in near real time that she was able to utilize and look at that validation. And I think it did come out fairly well, or at least I was able to have those in the ballpark for the snow amounts. That helps.
All right. In addition, let's see, as I wait for more questions in the chat here, another question for you, Aaron, here is, how do you see this combination of LEO satellite and land information system data being applied moving forward to improve NWS's IDSS for future events?
I think it's going to be a combination of what Clay and his group was able to do, and this other this new effort of getting this third version high resolution land surface information. But it will be the training with the forecasters of how to incorporate these two data sets and then to take action. And I think a lot of it's on the land surface information of how to assess that, not just our forecasters, but also our hydrologists at the River Forecast Center. And so I think it's imperative for us to have an understanding of the land surface to understand what type of impacts we can get. So, but we need to know what happens in the atmosphere. So it's the combination of the atmosphere and the land together. So it's imperative that we look at both of these fields together and to help us with the impacts in the IDSS. So that's essentially what we're trying to do. So helping our forecasters identify when that risk is, and utilizing these two types of products in the future will definitely improve our messaging to those impacts of flooding and or landslides.
Great. And then I see that Jonathan Case added some more information there for clarity as well. So we appreciate that, Jonathan. And then I think I have one more question, at least from my side, for you, and we'll see if we get any last questions in the chat. But with all that rainfall, Aaron, over your CWA, so typically over the course of a year, over your CWA, how many atmospheric river events do you guys typically experience out there?
Oh man, there's a lot of them. It depends on, we have climatology. I've been working with some people in Scripps, Center for Western Water Extremes, and we've been doing a lot of research on our climatology. And so we get a lot of atmospheric rivers just because of where we're at in the globe, but the impacts are not as much because of we're a rainforest, like we were saying. We can take a lot of rain, and when an atmospheric river is at a lower end, we may not see a lot of impacts and such, but so it's still atmospheric river. So we see a fair amount of them, but it's really only about like 9 to 10 days out of the year we receive really extreme precipitation associated with these extreme or very strong long duration atmospheric rivers. And so those are, it's really about 9 to 10 events that, or days out of the year, that we really need to monitor these events well and be able to message what impacts can take place before they happen. That's what a lot of the work is being done with these atmospheric rivers. Is it's not just the strength, but what are the impacts associated with them? And one of those impacts is flooding and landslides. And so we have a better idea about these atmospheric rivers and what causes these impacts, not just the strength of them, but the impacts associated with them. Then I think we are getting to a better messaging avenue for the Weather Service and for our customers.
Awesome. Well, thank you, Aaron. And as of right now, I don't think I see any other additional questions in the chat. So I'll come to a close now, and I'll turn it back to Jordan for any final remarks. Go ahead, Jordan.
Oh, thank you so much, Jarrell, for leading that discussion. And Aaron, always appreciate the perspective from Alaska. And thanks to everybody for joining today. I'll have just one little piece of trivia for you. So Joe Juneau was a prospector that founded Juneau, Alaska. Joe Juneau's cousin, Solomon Juneau, founded Milwaukee. So anyway, piece of additional information from the Satellite Book Club, Milwaukee, Wisconsin. All right, so Really appreciate those of you that were able to join us today. Obviously, there's a high impact tropical weather event in the southeast, and I know that that might have kept our attendance numbers down today, but hopefully folks will be able to catch the recording. As a reminder, as has already been announced, Thursday, October 3rd, the Satellite Book Club continues. We are finalizing details for a presenter, so rest assured we will have a presentation, but we don't have someone to advertise yet. So look out for an email on that. In the meantime, if the Tower S team can be of any assistance, Kashad and Emily, as I said at the beginning, they're great. Reach out to them. The Tower S channel on Slack is another way to get in touch with the team. With that, I want to once again thank everybody for being with us. Thanks to our presenter, first-time presenter, Aaron Jacobs. Jarrell, thank you for moderating, and hope everybody has a great start to fall. Take care.